So we're going to take a look at trig identity proofs. And the whole concept of trig identity proofs actually stems from the unit circle. So if you're not familiar with the unit circle, there's one on the left fully filled out. But essentially what the unit circle is we've taken a circle whose radius is 1, and we've kind of deduced these different values and points from it. If we take that same unit circle, if we were to overlay it on a Cartesian coordinate system, the xy plane, we would see that it lines up perfectly where its radius is 1, so the diameter of the circle would span from +1 to -1. And the first identity we're going to take a look at, and I'm going to show you the proof for, is sine squared theta plus cosine squared theta equals 1. And where this comes from is this is regardless of whatever angle I'm dealing with. This comes from Pythagorean's theorem. So if I were to take this circle, right, and we were to look at the radius, and I were to essentially make a little triangle inside this circle where my radius becomes the hypotenuse of this circle. So remember, it's from the unit circle. It's very important to note that this hypotenuse is 1. Well, the angle that I'd be looking at would be this angle here, theta. And what's adjacent to that? This side that lines up right on my x-axis. So these would be my x values. And what's opposite that? Well, it's actually parallel to my y-axis. So these would be my y values. And if I remember that sine of an angle is opposite over hypotenuse, I can rewrite the sine of that angle on an xy coordinate system to be, instead of saying opposite, I'm going to say y over, remember the hypotenuse is just 1, which anything divided by 1 is itself. So my y value is that sine of that angle value. I can do the same thing to find the x value. Instead of using sine, though, I'm going to use cosine of an angle, which gives me the adjacent side over the hypotenuse. And that just translates to the cosine on the xy coordinate system is going to be the x value. So that x value over 1. So x is equal to the cosine of that angle. And if I remember Pythagorean's theorem, which essentially states the sum of the sides squared is equal to the hypotenuse squared. So you might have seen it in the form of a squared plus b squared equals c squared, and that would be for, and again, Pythagorean's theorem is only for right triangles, so that would be for some right triangle where this is one of the sides, this is another side, and this is the hypotenuse, which we call c. We can translate it to this triangle that we're dealing with here. Well, our sides are x and y, so we can say that that's x squared plus y squared equals this hypotenuse squared, right? Well, what did we just say our x value was? Our x was the cosine value. So then that means that's cosine squared. And what did we just say our y value was? Well, that's the sine value. Sine squared. And what did we just say the hypotenuse was? Well, that's 1. And 1 squared is still just 1, so that equals 1. So that's where this particular trig identity comes from. The next Pythagorean theorem identity we're going to look at is tangent squared theta plus 1 equals secant squared theta. Where this one comes from is actually pretty straightforward, if not hard to see. But we take the first one that we just found, so sine squared theta plus cosine squared theta equals 1, and we divide the whole equation by cosine squared theta. Now, you might be asking yourself, why on earth would you want to do that? But there are some uses where the second identity is actually extremely helpful. So if I divide an equation, so long as I divide everything by that value, the equation still stays equivalent. So I have to divide cosine squared theta from everything. Okay, and sine over cosine is tangent. So let's take a moment real quick just to kind of show that those two things are equivalent. So the tangent of theta, if you're thinking SOHCAHTOA, TOA, T-O-A, tangent is the opposite over the adjacent. So if I look at what is the sine of an angle, well, that's the opposite over the hypotenuse. If I look at what is the cosine of an angle, well, that's the adjacent over the hypotenuse. So how can I put this in terms, what is the sine divided by the cosine of that angle? Well, that's the same as saying opposite over hypotenuse over adjacent over hypotenuse. Now, I do not like to divide fractions by fractions. So the way that I undo that is this opposite over hypotenuse divided by adjacent over hypotenuse. That is the same as saying the opposite over the hypotenuse multiplied by the reciprocal that's in the denominator. So that means the hypotenuse over adjacent. Now we see our h's cancel and left with opposite over adjacent, which is tangent. So now that I've kind of proven that sine over cosine is tangent, well, all sine squared over cosine squared is going to be tangent squared. So this becomes tangent squared theta plus, well, cosine squared divided by cosine squared, anything divided by itself is just 1. So that becomes 1. And then 1 over cosine squared is actually going to be secant squared. So cosine is equal to adjacent over hypotenuse. Secant of that angle is equal to the hypotenuse over the adjacent. So I'm running out of room here, but hopefully we can kind of see that 1 over cosine theta is equal to secant theta. Running out of room. But those two things are equivalent, which I'll list here in our our trig identities. So the other way I can write that then is just saying secant squared theta, which now we see is the second Pythagorean identity. Right, and the third Pythagorean identity we're going to talk about is 1 plus cotangent squared equals cosecant squared. So we take the same original Pythagorean identity that we got, the sine squared theta plus cosine squared theta equals 1, but instead of dividing by cosine this time, we're going to divide by sine squared. So sine squared theta divided by each term. And this sine squared over sine squared, that just becomes 1. If sine over cosine was tangent, you might already be thinking that cosine over sine is cotangent. You'd be right. Cosine over sine is cotangent. And I dare you to pause the video and work that out. You'll see that it ends up being essentially where cotangent is equal to adjacent over opposite. But you're welcome to pause the video and work that through yourself. So then this becomes cotangent squared theta. And then if 1 over cosine was secant theta, then I'm running out of room here, but 1 over sine is equal to cosecant theta. And the way I remember this is it's opposite what you think it should be. So it's natural to think that the c should go with cosecant, or cosine should go with cosecant because they both start with c's. But a good way to remember it is just opposite what you think it should be. So 1 over sine is cosecant theta, or in this case we have 1 over sine squared, so that's cosecant squared theta. And that is the third Pythagorean identity.